So what is light really? I mean, we're surrounded by it, but what is it fundamentally? For more than a century, we've had a pretty solid answer. But what if that answer is just scratching the surface of a much, much deeper reality? Today, we're going to explore a radical idea from a framework, well, it's called the methane meta-universe, but let's just call it the MMU, okay? And it proposes a whole new architecture for space-time itself. All right, let's dive right into this. It's a massive question, right? Standard physics tells us light is an electromagnetic wave. And hey, that works perfectly. But the MMU framework comes along and asks a really simple question. A wave in what? It suggests that space-time isn't just this empty void. No, it's a dynamic, structured thing. And light is just a vibration running right through it. For over 150 years, our whole picture of light has been built on this absolute bedrock, Maxwell's equations. They're beautiful, really. They perfectly describe this elegant dance between electric and magnetic fields, creating the waves we call light, all zipping along at the speed of light, c. They are just incredibly successful. So you've got to ask, why on earth would anyone even bother looking for another answer?
Well, here's the thing. The MMU doesn't just toss Maxwell's equations in the trash. Not at all. Instead, it proposes they aren't the fundamental truth. They're what you get when you look at a much deeper, more intricate structure of spacetime, but only under just the right conditions. It's kind of like looking at a lake and seeing a smooth, glassy surface. You know that's not the whole story, right? You know it's really made of countless individual water molecules. The MMU is saying Maxwell's equations are like that smooth surface.
Okay, so to really get how the MMU explains light, we have to start at the very beginning, with its most fundamental claim, that spacetime itself has a hidden architecture, a basic building block that makes up the very fabric of our reality. In this view, spacetime isn't some smooth, stretchy sheet like we often imagine. Nope. It's a discrete lattice, like a crystal, and it's built from this one fundamental unit, the dual-tetrahedral year cell. Just try to picture it, all of space, everything, constructed from these tiny, interconnected geometric structures. But this is where it gets really cool. These building blocks aren't just sitting there statically. Each one is like a tiny little engine, and it has 3 hidden ways it can vibrate. You can think of them as the most basic ways a tiny piece of space-time can, stretch or twist or even change its size. And these 3 hidden modes, they are the absolute key to everything. So you've got W2, which corresponds to an electric or a stretching response. Then you have W3, that's a torsional or twisting mode, and that's linked up with magnetism. And finally, there's W4, a volumetric mode that controls the cell size, and the MMU connects that one to gravity. Okay, now we hit a really crucial rule of the MMU. It's called the projection principle. And what it says is we can never directly see these hidden vibrations. Imagine you have some complex 3D object spinning around, but you can only see its 2D shadow on a wall. Well, the MMU proposes that all the physics we experience, time, energy, forces, the whole shebang, is just the shadow that these hidden vibrations cast onto a single observable dimension, W1. All right, so we have these hidden vibrations happening in the background. But how does that explain light? Well, according to the MMU, light isn't some separate thing added to the universe. It's what happens when 2 of these hidden modes start vibrating together in a very, very specific way. The part of this internal spacetime engine that's responsible for light is what they call the Maxwell sector. That's the subsystem where the electric mode, W2, and the torsional or magnetic mode, W3, are coupled together. So get this, electromagnetism isn't something that's just happening in spacetime. It's a joint response of spacetime itself, of its own electric and magnetic channels. And this leads us to the absolute core idea. Light isn't something traveling through a passive, empty vacuum. Light is the vacuum vibrating. It's a bit of a mind bender, I know. But think of it like sound. Sound is just a collective vibration of air molecules, right? The MMU says light is a collective vibration of spacetime's own hidden structure. But wait a minute, that raises a pretty big question. If this deep hidden structure is really there, why does our world look so perfectly described by Maxwell's equations? This brings us to the aha moment of the whole theory. It turns out this perfect world only appears under one very specific condition. Yep, it turns out that for a wave to travel perfectly through this spacetime lattice, one incredibly simple and elegant condition has to be met between its internal properties. And here it is, K2 equals K3. That's it.
This basically means the stiffness of the electric vibration is perfectly balanced with the stiffness of the magnetic one. Imagine a material that resists stretching and twisting in exactly the same way. When space-time hits this perfect balance, something truly incredible emerges.
Right at that precise point of balance, the lattice suddenly supports a whole new kind of collective excitation, a massless wave that travels without dispersing. In other words, what pops into existence is a wave that behaves exactly like light. And just like that, Maxwell's world appears. Okay, so if light just emerges from this lattice, what about all those famous constants of nature that go along with it, like the speed of light itself? Well, this is where the MMU offers maybe its most profound reinterpretation. You see, in standard physics, fundamental constants like the vacuum permittivity, epsilon naught, and permeability, mu naught, are just inputs. They're numbers we measure and then plug into our equations. But in the MMU, they are derived properties. Epsilon 0 becomes the electric compliance of that W2 mode. Mu 0 becomes the magnetic compliance of the W3 mode. And the speed of light, see? It's no longer some cosmic speed limit. It's the intrinsic speed of this coupled deformation through the spacetime lattice. They're not axioms, they're outcomes.
So, what's the takeaway here? Is this whole thing meant to be a complete replacement for modern physics? The MMU's answer to that is a very clear no. The goal isn't to replace what works, it's to explain it. And the change in perspective is huge. The standard view treats the fundamental constants of nature like axioms. They're just numbers you have to accept and plug in. But in the MMU view, those constants are the results of the geometry of spacetime itself. They're telling us how that underlying lattice stretches and twists and vibrates.
So let's be super clear. Maxwell's equations aren't wrong. They work perfectly. They're just not the whole story. They shift from being a fundamental law of nature to being an emergent property, much like the laws of temperature and pressure emerge from the chaos of individual molecules. And that brings us to our final big thought. The MMU answers what is light by saying it's the observable limit of spacetime's own electromagnetic structure. But if light is an emergent property of the spacetime lattice, you have to wonder, what else is? What about gravity, or even matter itself? Now that's a question for another explainer.